Hi there, guys. My name is Wolford, and I'm a senior math tutor. And today I'll be covering 10 questions related to calculus and limits and derivatives. So a little bit backstory upon myself. I graduated from McMaster with a major in biochemistry and a minor in mathematics. And yeah, let's just jump right into these questions. If you have any other issues or problems with your homework, tests, or assignments related to calculus or mathematics or algebra, please submit them through OneClass and we'll get to them as soon as possible. Okay. So the first question reads, how do you find the derivative of a given equation? So how do you find a derivative of a function? First of all, we need to define what a derivative is. So there's multiple ways to define a derivative, but I like to define derivative as such. Let me find the right pen first here. Okay. Okay, here. So a derivative, we write, so if we have a function, let's say f of x, for example, then our derivative is going to be f prime of x. And it is simply the limit as h approaches to 0 of this expression here. So this is the derivative of a function at point x, which is the limit as h approaches to 0 of f of x plus h minus f of x divided by h. So the limit basically calculates the behavior of the function at the given point. And it basically tells us, oh, what is the function going to approach as h comes to be less than tends towards 0, basically. So this is kind of the definition of a derivative. Another definition that we can use is f prime of, let's say, a of the limit as x approaches 0 of f of x minus f of a over x minus a. So this is not a way that we can define a limit. So basically, we're trying to evaluate the derivative of a point, and we're calculating the limit of it as the function approaches that point. So that's what these two definitions tell us here. Okay, so we're going to use the first definition to calculate the derivative of our example here. So the junior tutor gave us an example of f of x equals x squared plus 2x plus 1. Okay, so with this in mind, we're going to use the first definition here. So we need to calculate what f of x plus h is, okay? So f of x plus h, we're just going to plug in x plus h into each of our x's in our function here. So we have x plus h squared plus 2 times x plus h plus 1. All right, so that means that f of x plus h minus f of x divided by h is going to be given by x plus h squared plus 2 times x plus h plus 1 minus x squared plus 2x plus 1 divided by h. And this simplifies to 2xh plus h squared plus 2h divided by h. Cool. So if we were to simplify this even further, we can get rid of all the h's on the numerator and the denominator. So we're just left with 2x plus h plus 2. Okay. All right. So now we're going to evaluate the limit of this. Okay. So the limit of as h approaches 0 of 2x plus h plus 2. What is that equal to? So we're just going to sub in h equal to 0 here, and we're going to find the limit. And that's going to equal 2x plus 2, which is the derivative of this function, x squared plus 2x plus 1. So by using this limit definition of a derivative, we're able to calculate the derivative of this function. And maybe later in the lesson, we'll cover some of the tricks and techniques that we use to calculate the derivative of different kinds of functions, like power functions, the product of functions, the sum of functions, and the division of functions. So we're able to do that with different techniques other than calculating the limit, using the limit definition of a derivative. Okay. So other than that, the solution is correct.